Good morning. My name is Jeff Perkins, and I'm Vice President of Business Development for ERS. ERS is an energy engineering firm, active in energy efficiency programs across the country, providing both evaluation and implementation services. This presentation was done for the AESP Spring Conference in 2016, which was held in Philadelphia in May. The original working title of this presentation was Packaging EM&V Systems into Building Retrofit Projects, and it was done as a rapid fire session. Rapid fire session is a 10-minute presentation, as much about making a point or making a case as it is about making a presentation. My working title turned into the title of the presentation, Ubiquitous Data Harvesting. And so I would like to redo that presentation for you here now. Ubiquitous Data Harvesting. I'd like to start by reminding everybody that energy efficiency has been and continues to be an incremental effort. For anybody that's been in energy efficiency for any time, we're on our second, third, fourth, fifth generation of technologies of various systems, each one more efficient than the one before it. The places we go are the places we've been, they're the places we will go in the future. The two F's, finance and physics, will tell us when we get there. And until that time, in a certain manner, today's post is tomorrow's pre. Even the why and what has evolved over time. If you go way back 35 years ago when all this started, efficiency was merely an objective. We were out to educate consumers. Bill stuffers and energy audits were the tasks that were done. Full stop, that was it. Energy audits, yes, they were automated, and yes, they did even have billing analysis. But there was no more than that, just educating the customer. Quickly, everybody realized that energy efficiency could be a resource, and demand-side management flourished. Across the land, people made money, and yes, even utilities made money. That era was interrupted by deregulation. But even post-deregulation, efficiency emerged, and this time as a public good. Fund it with system benefit charges, deliver it with third-party administrators, and oftentimes utilities. Measure it, and above all, sometimes it seems, argue about it. And argue about it we have, but continue it does. I would submit to you that today we are already in the next era, and this era is efficiency as sustainability. Motivated and driven by the 3 C's, climate, carbon, and capacity. For the first two, climate and carbon, we don't need to change a lot about how we do things, except maybe we need to just do them faster so that we can impact those ends. The third one, however, capacity, requires some fundamental changes in how we think, because capacity is reliability, and that's what system planners are looking for. How reliable is energy efficiency? We debate it and argue it amongst ourselves every day, but ultimately we all believe in it, and we believe in its persistence, and we believe in its reliability. However, traditionally, planners have not explicitly included contributions of EE projects in planning scenarios at the substation level. The ISO may recognize it, may talk about us building the efficiency power plant, but at the substation level, by the time it gets there, it's been discounted to virtually zero. However, current critical infrastructure needs demand that system planners begin to accept it. So it's incumbent upon us, we in the industry, it's incumbent upon us to build in reliability, to build a reliability model for EM&V. And I submit to you that means we need to build in EM&V systems to the projects that we deliver. How are we going to do that? We're going to leverage existing trends. I love this chart. This is a heat map of the Internet of Things. It was done by these folks at Shodan that they pinged every device that had an IP address on the Internet. The red being higher density of devices, yellow and lighter colors being lower densities. And this was every device. This is about 2 years old, but every device that existed on the Internet. If there is for 1 minute a question about the ubiquity of the Internet of Things, I'll remind everybody that the last piece of information that we have from missing Malaysian Air, the 777 that went missing, the last piece of information is data from a jet engine, a sensor on a jet engine, reporting to the cloud. Self-reporting, in fact, to the cloud. That's the ubiquity of the Internet of Things. Why was that sensor on that airplane? Because sensors have gotten cheap. Low-cost sensors. Some people believe that the existence of smartphones has driven the cost of sensors down. It's quite the other way around. The low-cost sensors have enabled the technology that we have in our smartphone today. And it's because of fundamental changes in the manufacturing technologies for things like accelerometers, magnetometers, pressure sensors, temperature sensors, humidity sensors. Too many sensors to name. Manufacturing technologies that in the past, where it took tens of people to make a single sensor, today with tenths of people we can make hundreds of sensors. Orders of magnitude changes in the manufacturing techniques have driven the cost of these down, and the low cost has driven widespread adoption. To give an example of widespread adoption, I use the image sensor simply because that's the data that I happen to have. From 2000 to 2010, image sensor cost went down 25-fold on the left. 25-fold cost drop. On the right, driving volumes up 100-fold. That's widespread adoption. There are a multitude of sensors. Virtually every sensor we need to enhance our EM&V efforts has followed a similar curve where the price point has come down to make it totally achievable in systems today. For the energy geeks in the room, I would make a sidebar note here that infrared image sensors are following this same cost curve, albeit they started at a much higher point and they're coming down. But cell phones, 2 to 3 generations hence, we will be able to see infrared image sensors on your cell phone. This is what widespread adoption is all about. And ultimately the goal is data. This is my metaphor for data in a building, a pile of sand. We all know that buildings don't consume energy. People in buildings consume energy. So every time we talk about AMI data, I remind everybody we're talking about one piece of the puzzle, not both. Every time we in the energy industry argue about information or baselines or results, it's because of a lack of data. And we don't have enough data. When we talk about big data and limit it to just AMI data, it's a disaggregation, and quite frankly, we've been doing billing analysis and disaggregation for decades, and we understand the limitations. Yes, the analytics and the automation of it are going to advance our industry, and yes, automating those analytics is going to help us all. But if we're talking just about AMI, all we're talking about is looking at still piles of sand from a distance, and we're missing the opportunity for granularity. Granularity can be given to us by ubiquitous data harvesting with inexpensive sensors that exist today. And the granularity in that data is what can inform our decisions, inform our results, and drive EM&V, an evaluation of energy efficiency, and energy efficiency as capacity to a new level. That's about building in reliability, as I said, building a reliability model for energy efficiency, building in EM&V systems. It's what we're calling energy-focused, deep granular EM&V. That's edge EM&V. That is what this is about, is getting deep granular information to answer the questions that are so pressing in our industry. There are 2 ways to go about data harvesting. There's a data-oriented approach and a functionality-oriented approach. Data-oriented approach is get data, use it however. Think Google. Perhaps even think Nest. Think Facebook. This is what they gather information and then they figure out how they're going to use it later on. Versus functionality oriented, which is what we have been doing in this industry for a long time. We have a need, we draw a sample, we send engineers out with meters, we gather that data, or with surveys, we get the data, we know what we want, we gather it, we organize it, that's it, done, finished. What Edge M&V proposes is that we want to combine both of these. We want to take the best of both. We know we have a functionality-oriented approach. We have a need. We can get that data. We know what data to get. We can get that. But we can also enhance it with a data-oriented approach where we're gathering additional information that's going to help us answer the questions that so often we're unable to answer for lack of data. And we gather that data. It'll give us the flexibility to use that data for other endpoints, for other uses going forward. We all know the model of energy monitoring. We put sensors out into occupied spaces. out into occupied spaces, and we meter systems. We've done that, deploy and retrieve. That's been enhanced with remote monitoring, where we deploy, bring the information to a gateway, move it to the cloud. What we're talking about is ubiquitous data harvesting, where we're going to deploy sensors that are different into the occupied spaces. We're going to attach to systems. We're going to move that to a gateway. We're going to move that to a repository in the cloud. We're going to allow device provisioning. We'll give field engineers tools to interact with these sensors, and that's the system that can be deployed. It can be deployed by the project teams that are installing and the implementers. It can be deployed by building personnel. It can be deployed by evaluators if necessary, but ideally this is getting out there much earlier than when we get it. So about this is, again, the point is packaging EM&V into projects. How are we going to do that? We're going to leverage technology to get the granularity to deliver edge EM&V to utilities.